Okay, I will start explaining Unit 8, that is man-machine interaction. So we can also consider this as HMI, that is human-machine interaction. These are the contents. Design of use and maintenance. These topics we have already covered in Unit 4. Remaining topics I am going to cover in today's and tomorrow's class. Man-machine cycle, design of displays and controls, factors influencing the design of displays and controls. There are only a few topics in Unit 8. Okay, so in exam point of view, you can prefer this unit. In less time, you can cover all these topics. So objective is to apply the concepts of machine interaction. Okay, so this is the man-machine interaction cycle. So this is a very important topic of this unit. In most of the exams also, you can find a question related to this topic, that is man-machine interaction or human-machine interaction, that is HMI. Okay, so we are using many devices, instruments, okay, where we are communicating with the machine. If you consider a motorbike or car, okay, any machine, even CNC machine, lathe, okay, we are interacting with machine. Man is interacting with machine. Without this interaction, it is not possible to operate any machine, or it is not possible to drive a car, drive a vehicle. Okay, so that means even though machines are non-living things, we need to communicate with them. Okay, how man is going to communicate with a machine, and what are the design considerations that need to be followed while designing any instrument or any device, that we are going to discuss in this topic. Okay, so man machine interface. If you consider car, okay, you are driving, imagine that you are driving a car, and you have seen a traffic police, okay, so at some distance. Now you want to reduce the speed of car, okay, immediately what you are going to do, you will look at the display, okay, what is the current speed at which you are driving the car. Suppose if you are driving the car at 100 meter per hour, 100 kilometer per hour, and if you want to reduce it to 80 kilometer per hour, okay, first you have to identify at what speed you are driving the car. That you are going to identify with the help of display. So you look at the speedometer and you will see at what speed you are driving the car. So then you will see and you will sense the value of the speed. Okay, then after that you will take a decision. Okay, so I have to reduce the speed from 120, sorry, or 100 kilometer per hour to 80 kilometer per hour. That is the decision you have taken. Then you will implement this decision through controls. Okay, so you may, with the help of accelerator, you may change the gear. Okay, and so by using these controls, these are the controls. Okay, so you are going to make use of the controls which will control the speed of the vehicle. Okay, like gear, like um, accelerator. Okay, like that you are going to so control the speed. So here you are implementing your decision by using controls. Okay, so you are communicating with the machine with the help of controls. At the same time, machine is communicating with man with the help of display. Okay, that is the difference between display and control. So display is used for communication from machine to man, whereas controls are used for communication from man to machine. Okay, so you may press a button. Okay, you may switch on, switch off, you may rotate a knob. Okay, or you may input a program. There are many ways in which you can communicate with a machine. Okay, once you give inputs to machine with the help of controls, obviously machine will respond to that input. Okay, then so that change in the working condition of the machine is highlighted on the display, or that will be reflected in the display. So again, if you consider the example of reducing the speed of car, okay, you are driving at 100 early, okay, at present, so that will be displayed by the car. You will sense that now the car is running at a speed of 100 km per hour, you will make a decision to reduce the speed to 80 km per hour. Okay, then immediately, so you'll change the gear and you'll reduce the speed by using controls. Okay, when you give these inputs, machine will respond. That means the speed of the car will decrease, and again, to what extent the speed has reduced, that will be highlighted on the display. Like in this cycle will continue. Okay, so in this man machine interface, uh, sensing and decision making is the role of the man, or is the role of the operator of a machine. Sorry, operator of a machine is man. Okay, and controls, machine response and display, these are related to machine or any other equipment. Okay, and then other than these things, there are some other aspects that we need to consider. Okay, operational environment. Again, operational environment will have an impact both on machine and man. Okay, so operational environment may affect the working conditions of the equipment or machine, and also it may affect the capabilities of human being. Okay, like heat, cold, humidity, noise, vibration, and pollutants. Okay, because of pollutants, quite often, if we read newspaper, so we see that in Delhi, because of smog, people are unable to see the vehicles in front of them. So in these adverse conditions, how one can drive a vehicle? Okay, how the difficulty or the challenges of the driver can be reduced. Okay, so these are the challenges that need to be considered. So you have to design displays and controls such that it is possible for an operator, okay, to see the displays or to understand what is there in the display, even in adverse situations. Like that, you have to design displays. At the same time, you have to design controls such that even man is able to use these controls. Okay, so to change the status of the vehicle or equipment, even in adverse conditions. That is the requirement. That is the design requirement. Okay. Next, again, while designing any man-machine interaction or any HMI, you have to consider the capabilities of operator, capabilities of human being. It may be muscular capabilities related to the strength of the human being. Okay, it is related to physical strength, then vision capabilities, then motion, okay, movement capabilities of a human being, then aural capabilities, okay, how whether his ear is working properly or not, is able to hear this sound or not. Okay, so these capabilities need to be considered while designing this HMI. Suppose you might have designed a display because of the poor vision capability of a person. He may not be able to read what is there on the display. Okay, so that you have to consider who are the users of your equipment or device or instrument. Okay, based on that, you have to design this HMI. Okay. Man forms an important component of whatever we have discussed. Okay, that we'll once again we revive these points. Okay, man forms an important component of every operational system. The designer should ensure the compatibility of man with the rest of the system. Since again, simply someone cannot sit inside the car and he can drive the vehicle. For driving, it requires a lot of preparation, a lot of skill, a lot of training. Because okay, interacting with any instrument or any machine requires a lot of preparation. Okay, simply you cannot operate any machine, you cannot drive a vehicle. Okay, so that's why designer, the role of designer is, okay, you should reduce the complexity of any machine so that with less effort, someone is able to learn how to operate a machine, or someone is able to learn how to drive a car. Okay, like that, the design should be simplified by considering user friendliness of the product. Okay, the designer should ensure the compatibility of man with the rest of the system. That means man should be able to operate. Okay, so all the controls, properly. So that is the compatibility of man. Since the sensory decision making and muscular capabilities of the user of a system are largely outside the designer's control, the only way of ensuring compatibility is to design the system around the user. So again, so the physical or oral or even vision, motion capabilities of every individual is different. But so you have to consider who is the target audience or who are the consumers of the product or consumers of the machine. Who is going to operate a particular machine? Okay, by keeping that in view, so you are going to design these HMI systems. Okay, you have seen some of the vehicles are specially designed for physically challenged people. Okay, so some of the vehicles are designed for people who have better strength. Okay, so some are designed for people, okay, who cannot handle heavy weight. So we have seen various types of vehicles, even in two-wheeler, in four-wheeler. Okay, and even we have auto gear four-wheelers. The reason is considering the capability of the drivers, the person who is going to drive car. Okay, we have those facilities. Next, the main elements which constitute man-machine interaction cycle are machine displays information. Then man reads information and compares with what is expected. Man decides what control action should be taken. Man manipulates control. Machine responds to controls and the response is reflected at the displays. These things we discussed by looking at that figure. Okay. There are two man-machine interfaces in systems. Okay, so here you can see this is one interface. So display is part of the machine and sensing is the part of it is the role of the man. So this is one interface where display is communicating with man. Another interface is man is communicating with the machine. So that is this is one interface and this is another interface. Here machine is communicating with man, and in the second interface man is communicating with the machine. For communication from machine to man, display is used. For communication from man to machine, controls are used. Okay, one at which machine communicates with man through display, this is the one interface, and the other at which man communicates with the machine through controls. So this is the another interface. These two interfaces require sensory and muscular capabilities of operator respectively. Okay, so in order to look at the display and understand what is there on the display, okay, what it is displaying. So you need sensory capabilities. That means your eye must be able to read. Okay, so you should have very good vision. Okay, so that is the meaning. Okay, then in order to provide inputs to controls, okay, you should have better physical capabilities. You should have strength, okay, muscular capabilities, and also movement capabilities to manage these control systems of the machine. The display and control should be so designed that they are well within the abilities of people using the machine. Again, by keeping in mind the capabilities of operator or user of the machine, you have to design these things. The sensory and muscular abilities of man are influenced by the operational environment. Okay, even a person may be having very good vision. Okay, but during morning time, okay, if there is fog, then the vision capability of the man will be affected by the fog or even by the smog because of the pollution. Okay, and there are adverse situations of during rainy season, during winter season. Okay, the vision capabilities are affected by environmental conditions. Okay, that also need to be considered while designing human machine interface systems. Designer must consider the operational environment and its effect on man. So if a man turns on the wrong switch or accidentally bumps into critical switches because he is confused, reads a dial wrongly because he is unfamiliar with the peculiar gradations on it, runs a red light because he could not see it due to glare, or even falls asleep in his car while driving because of the monotony of the highway. The fault is of the designer who did not pay enough attention to the way a person's senses and his mind work. Okay, so it is the duty of the designer, or it is the duty of the one who is manufacturing a machine or a vehicle. Okay, this is duty to ensure the safety of the operator, safety of the user. You have to design a system such that it is user friendly, where the chance for miscommunication, the chance for misinterpretation is very less, or it is almost nil. Okay, you have to design such that, okay, so the chance for miscommunication is almost nil, because of this reason people may lose their life. Okay, if the speed is not displayed properly. Okay, if someone is driving car at 200 kilometer per hour, and if the car is displaying that you are driving at 100 kilometer per hour, then you know the consequences. Okay, by knowing that, by considering all adverse situations in which a person is going to drive a vehicle, or a person is going to operate any machine, okay, a designer has to pay attention and he has to address these issues. Otherwise, the company or the person who is designing these things, he has to take the responsibility. That is the meaning of this sentence. Okay, next, display. Okay, we know the role of display in man-machine interface. So display is going to communicate with man. Okay, communication from the machine to man is termed as display. The information to be displayed can be classified into following types. So operating conditions of the equipment. You have seen, okay, so if you're when you are operating an equipment, consider the pneumatic system that you are operating in hydraulics and pneumatics lab. Okay, so there you are, if you look at the pressure, okay, so you have to consider the pressure. Okay, at what pressure you are operating the pneumatic system, whether the pressure is 3 bar, 2 bar, 1 bar. Okay, that is the operating condition. So that is one of the example. Okay, at what pressure the system is operating. Okay, so for that also you have some displays. Okay, so by, if you look at the pressure gauge, okay, there is an indicator where you can identify the value of the pressure at which the pneumatic system is operating. Okay, that is one example. Indication of pressure in a boiler, or indication of pressure in a pneumatic system or in hydraulic system. Okay, that is one example. Like that you can find many examples related to operating conditions. Okay, if you consider a car, at what speed it is driving, that is the operating condition of the car. Okay. So next, input setting of a machine. Okay, so suppose if you want to change the input, okay, so you are going to make use of some of the displays. So what is the present value? Okay, or if you provide an input, okay, to what value you have to set the input value that will be displayed on the control panel. Okay, that is the input setting of a machine. That also require display. Okay, needle displaying, frequency tuning in radios. Okay, earlier or even today some are using radios. Okay, so if they want to get a particular radio channel, okay, so then they have to tune this. Okay, in old radios they have to tune to get the required channel. That is the input setting. Output indicators. Okay, temperature in a freezer, location of aircraft on a radar system. Okay, and even speed in the vehicle, that is also displayed by the output indicators. Status indication. Okay, railway signal, right, like red light for emergency. Then if you are using a weighing scale, then zero reading on a weighing scale, that will indicate Okay, so nothing is there in the weighing scale. Next, the information presented by the display must be perceived correctly by the operator. This is a design consideration. The displayed information is used by the operator for making decisions. Again, based on what is displayed. Okay, so operator is going to make decision. Some of these decisions must be made under conditions of acute physical and mental stress, and some must be made within very short intervals of time. Quick decisions need to be taken, okay, based on the displays. That's why displays are designed such that it is easy to interpret the information communicated on the display, such that the displays are designed in such a way. Okay. Thus, the information should be presented to the operator in such a manner that it facilitates decision making even under the worst of reasonably expected conditions. So, like if you are driving a car, if there is a possibility of accident, okay, quickly driver must be able to give input. Okay, quickly he must be able to realize how to reduce speed. Okay, how to stop the car. Okay, so how we should be able to interact with the vehicle. Okay, that you should know, and that should be easily understood by the person who is driving the car. All displays are not equally effective under all conditions. The guiding principle in the design of displays is that information for arriving. Okay, so because of there's a technical problem. Okay, so I will continue. Okay, all displays are not equally effective under all conditions. The guiding principle in the design of displays is that information should be presented that it allows the operator to use the information for arriving at decisions quickly enough and with least possibility of error due to perceived expectations. The sensory channels available to the designer are many: vision, hearing, touch, motion, thermal. Okay, so man can sense based on vision. Okay, he can see something displayed and then he can make a decision. That is one way. And also hearing. Okay, so if you are able to generate a sound, okay, so by that also is able to understand, okay, something is not going well with the machine, or even um, you can run a audio clip also. That is also possible nowadays. In cars, in some cars you can find, okay, when you sit on the car, if you have not put on the seat belt, you will get a audio message. Okay, so you have not put on the belt, seat belt, like that you will get a message. Okay, by that also, so a car is communicating with people sitting in the inside the car. Okay, then touch, with the help of touch also, so man is able to so sense. Then motion, thermal, we eat. Okay, so these are the ways in which a designer can make use of these possible ways while designing human machine interface or man machine interface. Okay, then factors that control the choice of the display: the rate of information input. Okay, so again, depending on the rate of information input, so you will make a decision to use which type of display should be chosen. Next, number of displays that compete for the attention of the operator. Okay, if you look at the displays in a aircraft or in a aeroplane, okay, you will realize, okay, in some cases uh, the pilot has to manage how many, or is to look into how many displays that you will realize, okay, if you look at how aeroplane will be operated by the pilot. Okay, so in such a situation, so it is difficult. You should a designer should pay more attention towards designing human machine interface then purpose of the display. Okay, so in some cases you will indicate only the status. In some cases you need to display a value. Okay, in some cases you need to display one or two information. Like that, there is a purpose for display. It may be indication of status. It may be indication of input value, output value. Okay, or it may be displaying a message during emergency. Next, culturally determined preconceptions of the operators. Okay, unknowingly, because of the society in which we live, we have some culturally determined preconceptions. That means most of the times we will read a sentence from left to right. Okay, we don't start reading from right to left because of the culturally determined reasons. Okay, some may be reading from right to left, but on an average generally, okay, so most of us will read from left to right. We'll start from this end and we will move towards right. Similarly, we are used to clockwise reading. Okay, so we'll read from left to right, we read clockwise, then we look from top to bottom, we don't look from bottom to top. Okay, so gradually, so usually we look first from top, then we move downwards. Okay, these are the culturally determined preconception based on the society in which we live. Okay, so we are going to learn a lot from the environment or from the society, so that will decide. And again, designer of HMI, he should consider cultural determined preconceptions. Environmental conditions under which the operator perform. Desirability of a permanent record. Okay, so these are the things need to be considered when choosing a particular type of display. Next, classification of visual displays. Okay, so moving pointer display, moving scale display, digital displays, and indicator. Okay, we have seen all these types of displays in various equipments, various machines. Okay, in lab, in day-to-day life. Okay, we have seen all these types of displays. Okay, moving pointer display, as the name indicate. So here pointer is moving, whereas the scale is stationary. Okay, that is the moving pointer display. In case of moving scale display, okay, so this graduation or this pointer is fixed. Okay, whereas the scale is going to rotate. So, or in this case, the scale is going to move, whereas this pointer is fixed. Okay, that is the moving scale display. Digital displays, we see, nowadays, okay, most of the displays are making use of this LED, okay, and digital display. Now, digital displays are widely used because of user friendliness of this type of display and indicator. Okay, even in vehicles we use indicator. Suppose if you are taking a right turn, then you will switch on a light. Okay, and again while driving, so you may use low beam, high beam. So they are the indicators. So like that also we make use of display. Next, some of the limitations of visual display. Okay, visual display depends on vision capabilities of operator or vision capabilities of one who is using the machine. Okay, or one who is operating the machine. So one of the limitation is resolution and viewing distance. Okay, it is difficult to view any information from a longer distance. Okay, so and that's why as a designer you have to consider resolution and viewing distance. Viewing distance ranges from 0.4 meter to few hundred meters. To obtain proper resolution between various markings, size of the display must increase in proportional to the viewing distance. Okay, if the viewing distance is more, okay, then the size of the display also should be large. Okay, so that a designer should consider. And there are some studies and there are some references for choosing the size of the display. Okay, or size of the it may be a symbol. Okay, or it may be a letter. Okay, for that also there are some considerations. This is one such example. Okay, minimum recommended dimension of scale markings for viewing under adequate lighting. So S is the viewing distance.
ಅಷ್ಟೇನಾ ಸರ್ ನೋಡಿದ್ರೆ 35 ಇರೋದು ಕಾಣಲ್ಲ ಮುಸ್ಕಿ
Okay, so minimum recommended dimensions of scale markings for viewing under adequate lighting. So S is the distance. Okay, so there are different indexes. Again, this depends on the value of S. S is the distance, viewing distance. Okay, the actual display and the location of the operator or user of the machine. Okay, considering that we have some indexes, major index, intermediate index and minor index. So where you have height and width of these graduations or scale markings. Okay. Next, viewing angle. Okay, so though the field of vision of human eye extends through an angle larger than 60 degree on each side of the normal. Okay, if this is the normal, that is if you look straight, that is the normal. Okay, so based on the observation, man can view up to 60 degree on left and right side. That is the general perception. Okay, so the eye can focus clearly over only a very small range. Okay, 60 degree ನಮಗೆ ಕಾಣಿಸುತ್ತೆ, but we cannot concentrate on whatever we are seeing. Okay, at a time we can view only a small amount of details or a small amount of area. So this is the representation where this is the straight line, then visual limit with maximum adverse eye rotation. So there are some angles. Okay, need not worry about these figures. Okay, what you have to consider is, so now 360 degree nodakagalla. So we have some limitation. Okay, so there is a viewing angle. So generally it is 60 degree around left and right, but ಅಲ್ಲೂ full 60 degree ಇರೋದೆಲ್ಲ ನಮಗೆ ಗೊತ್ತಾಗಲ್ಲ. Okay, so that we need to consider while designing. Okay, the area on which the human eyes can focus at any given moment is limited. The designer should arrange the displays appropriately in some logical sequence so that the need for searching is eliminated. Like the logical sequence may be from left to right. If the displays are arranged in circular manner, it may be in clockwise direction. Okay, so first display which need to be a operator need to focus. That first one should be placed here. Then in clockwise, he has to look into that. Okay. If you have a check dials A, B, and C in a particular order, the dials should be physically positioned in that order, going from left to right or from top to bottom, because these are the familiar ways in which we will look into information. Okay, while reading we will read from left to right. Again, while looking at any detail, okay, so if someone is standing in front of you, you look from top to bottom. That is the approach of us. Okay, that need to be considered while designing displays also. The eye naturally moves from one dial to the other in the required order, and this saves searching for the appropriate dial. Okay, if someone has to look into, okay, so three displays A, B, and C. Okay, so usually what we'll do is, so we'll consider this as A and this as B and this as C, and we will look in this order. Okay, that is one way. Another way is we'll start from top and then we go to bottom. Usually if we have two displays, we don't start from the below one. We'll obviously will start from the one at the top. Okay, so this is an example possible arrangement of display in an aircraft. instruments arranged in the natural sequence in which most pilots look for. Okay, this is the display in an aeroplane. Okay, you can see. So there are number of displays in an aeroplane. Okay, so that's why it is very challenging to design HMI for any aeroplane. Okay, there are number of displays and there should not be any confusion. So most of the concepts related to this HMI design will be considered by the designers of aeroplane. Okay, next illumination and adaptability. Okay, though human eyes can adapt to gradual variations in light intensities, it fails to adapt quickly to vastly differing intensities when the change is instantaneous. Okay, we have noticed if you go to a theater, okay, if you go late, okay, then it is difficult for us to adjust to the light. Okay, so if you move from light to dark, okay, it is human eye will take some time, or human will take some time to get adjust into that change from light to dark, or from even from dark to light. Okay, so while designing displays, this also need to be considered, illumination and adaptability. So these are the challenges. If are the, you can consider this as limitations or demerits with visual display. Okay, resolution and viewing distance, then viewing angle and illumination adaptability. These are the limitations of visual displays. Okay, so there are two topics remaining in this